Go.
If Tyler shoots a basketball with a weight of 0.72 kilograms at a hoop with a height of 3.5 meters, the force on the basketball would be the mass of the ball times acceleration. In this case, the source of acceleration would be gravity, which is 9.8 meters per second squared. So then you would take 0.72 kilograms being mass of the ball times 9.8 meters per second squared being gravity, which would be the acceleration in this case. This makes the force equal to 7.056 newtons. So force is equal to mass times acceleration, which is Newton's second law. And if you wanted to find out how much work the ball was doing, since you know the force of the ball is 7.056 newtons, you can easily find out how much work the ball was doing. Work is equal to the force times the distance. In this case, the distance is 3.5 meters, and the force is 7.056 newtons. When you multiply those together, you'll get 24.7 newtons, which is how much work the ball is doing.
Landon can dribble the ball down the court in 4.8 seconds, and the distance of the court is 28.65 meters. What would his velocity be? Since we know that the velocity equals distance divided by time, we can find out what his velocity is. It would be 28.65 meters divided by 4.8 seconds, which comes out to be 5.97 meters per second, which would be his velocity. If you want to see how much he was accelerating when he was going down the court, all you'd have to do is the velocity divided by the time. So in this case, his velocity is 5.97 meters per second, and the time would be 4.8 seconds. So you would do 5.97 meters per second divided by 4.8 seconds, and you would get 1.24 meters per second squared as his acceleration. When Tyler sets a pick for Mitch to get around a defender, Newton's first law of motion is getting proved. Let's say that Tyler doesn't set a pick for Mitch. The defender will stay in motion until an external force is acted upon the defender. Tyler would be an external force, making the defender stop being able to defend Mitch.
When Mitch shoots the ball, the force exerted on the ball will be proportional to the force exerted by his hand. This is all proven in Newton's third law of motion. After Mitch exerts a force onto the ball and it is put into the air, it hits the backboard, causing it to move backward, and the backboard also exerted an equal force on the basketball, which causes it to bounce off the backboard and go into the hoop.
Go.
When Tyler takes a charge from Landon in the paint, this explains inertia. If Tyler wasn't there, Landon wouldn't have been able to stay on the same path with the same velocity and wouldn't have been able to make the basket. Since Tyler was an external force, Landon didn't make the basket.
Go.
When Landon has 3 seconds left in the game and he is attempting to get the game-winning victory shot from full court, his best bet is to launch the ball at 45 degrees, because if your projectile motion is anything different, it'll either go too far or too short.
When Mitch plays indoors, he likes to wear his special shoes that help him with friction. As you can see, when Mitch runs and stops to change direction, his special shoes help him catch grip of the ground without slipping and falling.
It takes Landon 6 newtons to pull a basketball out of my hands with the force of 14 newtons. What is the coefficient of friction? All you have to do is take 6 newtons divided by 14 newtons to find out what the coefficient of friction, which would be in this case 0.43.
Right before Tyler passes it all the way down to the court, the energy that is being referred to is elastic potential energy because of the resistance of Tyler not throwing the ball and gravity. Elastic potential energy can be defined as energy that is stored when a body is deformed. Tension is his arms, which is potential energy, the elastic potential energy. Go.
When the ref is throwing the jump ball, the amount of gravitational potential energy can be found out. All you need to know is if he is high up. On average, they try to throw it 1.5 meters in the air, so we are going to use that as the height. Then you need to know the mass, which we said earlier, is that a basketball weighs 0.72 kilograms. The last thing you need to know is gravity, which is easy because it never changes. It equals 9.8 meters per second squared. Since you know all that, you can find your answer. Gravitational potential energy equals mass times gravity times height. So your answer would be 10.584 joules.
When Landon passes the ball to Mitch, the type of energy that is being transferred is kinetic energy. Kinetic energy is that the body possesses by being in motion. Since Landon threw the ball at Mitch going 4 meters per second, the mass of the basketball, as we know, is 0.72 kilograms. We can find out the kinetic energy of the basketball. All you have to do is take 0.5 times the mass times the velocity squared, and that will give you that kinetic energy, which will be 1.44 joules. The gravitational potential energy is equal to the kinetic energy in the problem, above where Landon is passing the ball to Mitch. This states in the conservation of energy law, which states that energy may be created or destroyed, therefore the sum of all energies in the system is a constant.